Okay, so in today's video, we are going to go from when we just had one linear inequality to two. And remember, anytime we have more than one equation or more than one inequality, we call that a system. So a system of linear inequalities is two or more linear inequalities that belong together, which means we can put them on the same graph. And the whole idea of putting them on the graph is to find our solution. So its solution to a system of inequalities is the set, and I say set because remember it's not one solution. When we graph an inequality, we have a whole shaded area of solutions. So it's a set of solutions where the shaded areas overlap because we're going to have two different ones. Where do they overlap each other? That's where we'll find our solutions to both. So let's take a look at number one. Number one here, it tells me I have a system. I can see that. I have two inequalities. Ooh, I like the fact that they're both already written in slope-intercept form. So they're already written in y equals mx plus b, which means I can just start graphing. I'm just going to start with the top one. Y is greater than negative x minus 1. So where do I start? Yep, I start at negative 1. And then my directions are, well, negative 1 is my slope, so down 1 over 1, down 1 over 1, or I could have went up 1, back 1. I'm going to put a few on there so I know that it makes sense. Next up, remember we have to determine solid line or a dotted line. Yeah, this is the I'm not touching you line. So this is definitely a dotted line. So I'm going to line it up. And I'm going to make my line. So there's one equation. Where do I shade? Greater than. Greater than. Okay, so I'm going to go up. So it would be this area here. Now you notice how lightly I shaded that? You can almost not see it. That's because I want to know where they overlap together, and I don't want my shading to be what throws me off. So be careful with how dark you shade, because that can really kind of confuse you later on. Now a system, I only have one on this graph. That means I need two, so I'm going to go ahead and graph the other one. Y is less than x minus 5, so I'm going to start at negative 5. And from here, my directions tell me positive 1, so up 1 over 1. I'm just going to kind of work my way across. I can also go down 1, back 1. I'm going to go back and look at my inequality. Is that equal to, is it touching the line or not touching the line? And that is not touching the line. So I'm going to go ahead and put another dashed or dotted line. Now I'm only paying attention to this line. I don't care about the other one. I'm trying to just like focus and just pretend like the other one's not even there right now. And it says less than. So less than this line would be everything on this side. And if I notice, that means that this section right here is where they overlap. So I can go back and shade that in darker. It's where the two shaded areas overlap is my solution. So you have to be careful. Where am I shading? And don't get confused on which section it is. Another cool tip here is if you have colored pencils, this is a really kind of a fun art project. If you are saying, using yellow and blue, well, the overshaded lap would be green. Or if you had red and blue, your overlap would be purple. So let's take a look. Number 2 is already in slope-intercept form. So pause the video, work it out, and come back and see what you think. All right, so important elements to check for. Did you remember that the top inequality needed a dashed line? Did you note that the bottom inequality needed a solid line? And that the area in which both of them overlap, so when I kind of shaded a little bit, I did like a light shade for each one, I noticed that they overlapped in this section here. And so I made that a darker shading area because we shade the entire area in which we find our solution set. So any coordinate in this set, if I plugged it back in, remember how we can check those, if I plugged it back in, so like if I pick the point here, I can see this one easy. Let's say that's 0 here, right? So 9, 0. If I plug 9, 0 in, it's going to work in both of those equations because anything in that shaded area makes it true. So I want you to pause the video. I want you to look at number 3 and number 4. Now remember, if it's not in y equals mx plus b, you have work to do first. All right, so welcome back. All right, looking at number 3 and number 4. So I just pulled out some colored pencils to see if that kind of makes it a little bit more visually, just a better, clearer picture for you. So in number 3, the first thing you had to do was make sure that you get that into y equals mx plus b for that first equation. Remember, as a mathematician, if you divide by a negative, that symbol needs to flip. So that's important. And then these were both equal to, that's important because both of our lines should be solid. And the purple area here is where when I shaded them, they overlapped. So again, I just did a red and a blue. The purple is where they overlapped. If you look at our second one here, remember our x is less than, that's like vux. So we know it's a vertical line with an undefined slope. And I shaded to the left, less than, so it was red. But you can't see much of the red anymore. You can only see the very tip because when I took that blue for the next line and I shaded over, my red became purple. And that is my shaded area in which both sections overlap. Notice here when you solve this equation, your symbol did not flip because as a mathematician, you divided by a positive. So the symbol stays as is. So let's just take a quick at number 5 and quick look, I should say, at number 5 and number 6. So pause the video, try those out, and then come on back. All right, so I have wrapped up both of those problems, number 5 and number 6. Remember, y equals mx plus b. You have to do that first. Then you have to double check. Am I going to have a dotted line? I'm not touching you, I'm almost touching you, but not actually touching you? Or am I going to have a solid line? Yes, I'm actually on this line and I'm part of the solution. And then after you get those graphed, you have to look, am I greater than or less than? I need to shade which side is the solution to each equation. And then when they overlap, the overlapping shaded area, that is your actual solution. Any coordinate within that area, any coordinate in that area is a solution to that system. So look at how many different ones. I mean, we couldn't even begin to actually list those out. So take your time on these. Make sure that when you're doing your practice, you follow the videos to help guide you there as well.